Okay, now we're going to talk about points of inflection. All right, and what it means. We don't mean voice tone here, although we could, almost. Write down the definition of a point of inflection. Pretty much, if you have a function, and that function needs to be continuous on an open interval, and let C be a point in that interval. If the graph of f has a tangent at C, f of C, then this is a point of inflection if the concavity changes from up to down or from down to up. Now, we can see that this point right here, we actually have a vertical line, and we'll discuss those. Now, Theorem 3.8 is really a good theorem. Let FC be a point of inflection on the graph of f. Either the second derivative of f evaluated at C as 0, or the second derivative does not exist. All right? So we're going to check for our second derivatives, and we're going to see where it's 0 and where they don't exist. And these are our inflection points. Okay, let's find our points of inflection on x to the fourth minus x cubed. So the first thing we need to do is, well, if we look at the graph, we can kind of see where maybe they are. But let's start by taking the derivative. The first derivative is 4x cubed minus 12x squared. Okay, the second derivative is 12x squared minus 24x. Now I'm going to factor this because I can. It'll make my interval seem a little easier. Now it's defined everywhere. Y double prime is defined everywhere. So I'm not going to worry about that, the F-I-N-E-D. Okay, now let's look at where it's 0. Where's y? Where is y double prime equal to 0? Where's the second derivative 0? At x is 0 and x equals 2. Let's see. X equals 0, x equals 2. Okay, you know what? That just, yeah, that's kind of making sense. Do you see how it kind of curves up here, down, and then it curves back up? So let's check our intervals from negative infinity to 0, and then from 0 to 2, and then from 2. Now I'm kind of upset because I'm not going to be able to use 0. So what are some good numbers we can pick? I like 1. So let's use x equal negative 1. Let's use x equal 1. And then simple. All right. What is the sign of f? I don't know. I keep putting f primes. These are f double primes. All right. Y double prime of negative 1 is 12 times negative 1, negative 1 minus 2. So this whole thing is going to be positive. So y double prime of negative 1 is positive. So this is concave up. What about at x equal 1? Y double prime of 1 is 12 times 1 minus 2. Ah, this is negative. So y double prime of 1 is negative, so it's concave down. Let's pull x equals 3. Y double prime of 3 is 12 times 3 minus 2. Well, this whole thing is positive. So y double prime is positive, so this is concave up. And lo and behold, that's kind of what we discussed at the beginning. All right, your turn. When you're done, stop the video, go on to the next one, finish your homework. Good luck.